Today we are going to study the field winding current versus load current characteristics and terminal voltage versus load current characteristics of a three-phase alternator for the different loads, that is a three-phase inductive load and three-phase capacitive load. Now we can see the circuit diagram for the today's experiment. If you observe this circuit diagram, it is same for the first and second experiments also up to load. At load we are using the three-phase inductive load and three-phase capacitive load, and procedure for this experiment is we have to vary the load current from 0 value to near the rated load current values in steps, and at each load step we have to maintain the rated speed of prime mover, that is 1500 rpm, by adjusting the external field winding resistance of DC shunt motor, and also we have to maintain the rated terminal voltage across the stator winding terminals of an alternator by adjusting the DC supply which is given to the field winding of an alternator. Then we have to note down the readings of field winding current and load current of an alternator. Then we have to vary the load from full load to no load in steps, and at each load step we have to maintain the rated speed of prime mover, that is 1500 rpm, by adjusting the external field winding resistance of DC shunt motor, and also we have to maintain the constant field winding current which is same as at full load value. Then we have to note down the readings of terminal voltage and load current of an alternator. This is our three-phase salient pole synchronous generator, and this is the nameplate details of three-phase generator. It is having rated RPM is 1500 RPM, frequency is 50 Hz, rated voltage is 415 volts, and stator terminals are connected in star connected. It is having 4 poles, and this is the DC shunt motor. It will be acted as a prime mover for the synchronous generator or alternator. Now we are going to switch on the MCB, and we are going to switch on the supply for single phase variac. Now we are going to start the DC shunt motor by using the 3-point starter. Now the speed is 1475 rpm. By adjusting the external field winding resistance of DC shunt motor, we can adjust the speed to 1500 rpm, and by adjusting the single phase variac, we can adjust the current through the field winding, and by adjusting the current through the field winding, we can adjust the terminal voltage across the stator winding terminals with the rated voltage, that is 415 volts. And if we observe the load is all the switches in the capacitive load are in off position, means it is at a no load condition. At no load condition, we have maintained the rated terminal voltage and rated speed. Now we are going to take the readings of field winding current, that is 10 amperes it is showing, and current through the load is 0 amperes. Now we are going to increase the capacitive load and adjusting the we are going to set the terminal voltage of an alternator to 415 volts, and now the speed is showing 1500 rpm. At this condition, current through the field winding is 8 amperes, and current through the load is 1.15 amperes. Again we are increasing the capacitive load, and then by adjusting the single phase variac, we are going to set the 415 volts the field winding current is 5.4 amperes and the current through the load is 3.48 amperes. Again we are increasing the capacitive load and we are going to adjust the terminal voltage to 415 volts by using the single phase variac. And now the speed is 1500 rpm and the terminal voltage is 415 volts. At this condition, current through the field winding is 2.4 amperes and current through the load is 5.7 amperes. Again we are increasing the capacitive load and by adjusting the single phase variac we can set the 415 volts terminal voltage. Speed is 1500 rpm. At this condition field winding current is 0.8 amperes and current through the load is 6.8 amperes. We have achieved the rated current of an alternator. Now we are going to reduce the load. At this condition we have to maintain the 0.8 amperes field winding current and the speed should be 1500 rpm and we have to note down the terminal voltage and current through the load. At this condition field winding is constant. It is 0.8 amperes and terminal voltage is 307 volts and current through the load is 4.2 amperes. Now we are going to decrease the capacitive load and we have to maintain the constant speed and constant field winding current. Now it is field winding current is 0.8 amperes. At this condition terminal voltage is 118 volts and the current through the load is 0.9 amperes. Again we are decreasing the load and here we have to maintain constant speed and constant field winding current, that is 1500 rpm and 0.8 amperes of field winding current. And then we have to note down the terminal voltage and current. Here terminal voltage is 69 volts and current through the load is 0.15 amperes. Now we are going to switch off the load completely and then speed is 1500 rpm and here field winding current is constant 0.8 amperes. At this condition terminal voltage is 58 volts and the current through the load is 0 amperes. With this reading we can plot the field winding current versus load current of an alternator and also we can plot the terminal voltage versus load current characteristics of an alternator. Now we are going to decrease the output of single phase transformer and we are going to switch off the MCB and we are going to connect the three-phase inductive load. Now we are going to connect the three-phase inductive load. For that we have taken one TPST switch, means triple pole single through switch. First we are going to take this RYB terminals to we have connected this RYB terminals to one side of this switch, RYB terminals. Other side we have taken these three terminals and we have connected to three-phase variable loading inductor we have connected. By using this we can connect the load and we can disconnect the load, 3-phase inductive load. Now we are going to switch on the MCB and we are going to switch on the AC supply for single phase variac. We are going to start the DC shunt motor by using 3-point starter. Now speed of alternator is 1478 rpm. By adjusting the external field winding resistance of DC shunt motor, we can set the speed of alternator 1500 rpm. Now by using the single phase variac, we are going to set the 415 volts terminal voltage of an alternator. If you observe this switch, now it is at off position means we have not connected the 3-phase inductive load. It is at no load condition only. At this condition, speed is 1500 rpm. Terminal voltage is we have maintained 415 volts. At this condition, field winding current is 10.4 amperes. And at no load condition, current through the load is 0 amperes and field winding current is 10.4 amperes. We have to note down these two readings by maintaining constant terminal voltage and constant speed. Now we are going to close the TPS switch. Now this inductor will draw the current. At this condition, we have to maintain constant terminal voltage and 1500 rpm rated speed. Yes. Now we have maintained the constant terminal voltage 450 volts and speed is 1500 rpm. Now we can note down the field winding current is given as 11 amperes and current through the load is 0.5 amperes. You have to note down this speed. Now again we are going to open the switch, open the TPS switch, means we are disconnecting the 3-phase inductive load. At this condition, we have to maintain the constant field winding current and constant speed. Now it should show 11 amperes of field winding current. It is same and speed also same. Now 1500 rpm. At this condition, we have to note down the terminal voltage and current through the load. Here current through the load is 0 because we have disconnected, and the voltage across the stator winding terminals is 424 volts. Now we are going to switch off the MCB and single phase variac. With these readings, we can draw the field winding versus load current characteristics and terminal voltage versus load current characteristics of an alternator. Here we have noted the observation values of load current and field winding current for the 3-phase star connected capacitive load. By maintaining the constant terminal voltage 415 volts across the stator winding terminals of an alternator, and also by maintaining the rated speed of prime mover 1500 rpm. If on x-axis we have taken the load current in amperes, on y-axis we have taken the field winding current in amperes. If we observe these characteristics, if the load current increases, then the field winding current will be decreased. to maintain the constant terminal voltage across the stator winding terminals of an alternator. In this, we have noted the observation values of load current and terminal voltage across the stator winding terminals of an alternator. By maintaining the constant field winding current of 0.8 amperes and rated prime mode speed of 1500 rpm for the 3-phase star connected capacitive load. On x-axis we have taken the load current in amperes, on y-axis we have taken the terminal voltage in volts. If we observe these characteristics, as load current increases, terminal voltage will be increased. And here we have also determined the percentage voltage regulation. Here full load voltage across the stator winding terminals is 415 volts and no load voltage across the stator winding terminals is 58 volts. And rated voltage of an alternator we know that 415 volts from the nameplate details. If we substitute these values, we got minus 86.02 percentage voltage regulation. Here we have noted the load current and field winding current values by maintaining the constant terminal voltage of 415 volts and rated prime mode speed of 1500 rpm for the 3-phase star connected inductive load. On x-axis we have taken the load current in amperes, on y-axis we have taken the field winding current in amperes. If we observe these characteristics, as load current increases, field current required will be increased to maintain the constant terminal voltage of an alternator. In this, we have noted the observation values for load current and terminal voltage by maintaining the constant excitation field winding current of 11 amperes and rated prime mode speed of 1500 rpm for the 3-phase star connected inductive load. On x-axis we have taken the load current in amperes, on y-axis we have taken the terminal voltage in volts. If we observe these characteristics, as load increases, rated terminal voltage will be decreased and here we have determined the percentage voltage regulation with respect to load step value of 0.5 amperes. Here no load voltage is 425 volts and full load voltage is not full load, we have taken at some load, that value is 415 volts. With respect to that load, we have determined the voltage regulation. Value will be 2.41%. In the second experiment, we have done the same procedure with the resistive load, and today we have performed the capacitive load, performed for the capacitive load and inductive load. So here for capacitive load voltage regulation is negative, for inductive load voltage regulation is positive. For resistive load we have seen it was also positive.